Today we will discuss how to interpret spirometry results. There are many different types of spirometers, but they all have the same basic principle. The patient is asked to inhale and exhale forcefully at least 3 times into the spirometer, which then records the measurements. The key measurements you should know to understand spirometry or lung function tests are FVC and FEV1. FVC is forced vital capacity. It is the same as vital capacity, but by definition it is the maximum amount of air expired after maximal inspiration. FEV1, which is forced expiratory volume in 1 second, is the maximum amount of air that is expired in the first second during the FVC maneuver. The ratio of FEV1 to FVC in healthy adults should be more than 70%. Now let's plot FVC and FEV1 on a graph and compare the normal lung function with obstructive and restrictive lung disease pattern. On x-axis we have time in seconds, and on y-axis is the maximum volume of air expired. It is measured in liters. Normally, when the patient blows out forcefully after maximal inspiration, the curve looks like this. So this is FVC, which is 5 liters, and FEV1, which is the air blown out in the first second, is almost 4 liters. Now let's calculate the ratio of FEV1 to FVC, that is 4 liters over 5 liters, which equals 0.8 liters or 80%. In obstructive lung disease, the curve looks like this. Now, if you remember from the previous lecture, we said that the patient with obstruction in the airways have difficulty during expiration. So when they try to blow out, almost all air comes out eventually, but very slowly. So FVC will be near normal, that is 4 liters, but FEV1 will drop significantly, which is 2 liters in this case. So the ratio of FEV1 to FVC in this case is 2 divided by 4, which equals 0.5 liters or 50%, which is way below normal. This means that in obstructive lung disease, forced vital capacity is normal or slightly decreased. Forced expiratory volume in the first second is reduced significantly, and the ratio of FEV1 to FVC is also reduced. On the other hand, in restrictive lung disease, the curve is like this. Here. Remember, here the airways are normal, so the patient will blow out normally, but due to the restriction in the parenchyma, the lungs cannot expand normally. So the overall capacity of the lungs is reduced, which means that both the FVC and FEV1 will be reduced. But if you look at their ratio, it's still 80%. Because even though both the FVC and FEV1 are reduced in restrictive lung disease, their values do not markedly differ from each other. Which means that in restrictive lung disease, FVC and FEV1 are reduced significantly, but FEV1 to FVC is normal. A quick recap of what we have learned today. Compare the obstructive pattern with the normal pattern. FVC is slightly decreased, but FEV1 is significantly reduced, and so is their ratio. In restrictive lung disease, both FVC and FEV1 are reduced significantly, but their ratio is normal. That's it for today. In the next lecture, we will discuss flow spirometry or flow volume loop. Take care. God bless you all.